Okay, with that, let's open. What we're going to do is this web panel, really unbelievable brain trust here, and I'm not being sarcastic like I usually would be, but really amazing. So each person's going to open with their introduction to the project that they're associated with and what their role is, and then we're going to see how much time we have left and try to make a session of it.
I guess I start because I've got the microphone. If we're a brain trust, I'm pretty sure I'm the brain stem here. So, my name is Todd Bittner. I work at Orbitz. For a couple years, I was pretty much the sole maintainer for the Erlang application that we run. That is basically our distributor cap for all the services we use. So while Erlang is fault tolerant, I was pretty much the single point of failure. Thanks. Yeah. I don't know. Should I continue or?
Yeah. Well, describe the what it does and its role within Orbitz.
Yeah, it's pretty simplistic. It is just a distributor cap. Essentially, all we do is we take a service request using HTTP, do a little bit of magic on it, and distribute it back using. So we use inets. I guess I'm the inets portion of everything here. So it's all old school and very built into the standard library. So all it does is it essentially takes something in through an HTTP server, does a little bit of magic on it, and spits it back out using HTTP client to a service. The service calls back and says, "Hey, this is what it used to do. It's changed a little bit since then." But then the service calls back, says, "Hey, here's your response," and then we return it to the original client. And relatively simple architecture, but it's extremely parallelizable because we use Erlang. It's very simple to write that as opposed to in other languages where you have to parallelize the stuff and have nodes talk to each other. That can be very difficult. Here, I think we're all the way up to 1,500 lines of code, including tests and comments.
So this is an example of saying we can tackle this problem directly with the TCP libraries in Erlang and do a lot of damage without a lot of code.
Yeah, probably saying damage might occasionally be the operative word there, but yeah.
Yeah, damage, yeah. Destruction. Yeah. Okay, cool, thank you.
I'm Steve Vinoski, and I work on Yaws, which stands for Yet Another Web Server. Yaws was started in the year 2000 by a guy named Klaus Vikström. Klacka has been a contributor to Erlang ever since like 91, I believe. He invented, binaries, the bit syntax, distributed Erlang, ets, dets, amnesia. I think you get the point. In my mind, he took Erlang from being kind of a research project to something that production developers like us use and could use in a production system. So he started Yaws because he didn't like Apache. He went to run a website for a sport he was involved in, and he said, I can't deal with this. I'm going to write my own web server. So the first commits happened in January of 2001, and it's still going. He's still involved. I joined the project in 2008. I was using Yaws as a web server and a video serving system. And I needed something that could handle many, many connections, like 30,000 connections, which was, at the time, now that's not so high, but at the time it was kind of hard to find things that could go that high. And Yaws could do that, so I started using it, and then there were things that it needed, so I added those, and Klacka said, why don't you just join the project? So I did. And today we have 3 committers. It's an active system, actively developed and maintained. It's got tons of features. You imagine what you need, I'm sure it's in there. If you like soap, it's got soap. If you like PHP, it's got PHP support. It's got FCGI, it's got server-side events, it's got WebSockets, it's got, you get the point. So it's a full-figured web server. And like I said, it's still actively developed and maintained by Klacka, me, and a guy named Christopher Fallet.
My name is Jesse Gumm. I am the current maintainer of the Nitrogen Web Framework. I took that over from Rusty Klophouse in 2011 because he was busy with Basho, and he just said he hadn't been spending any time with Nitrogen and he needed someone to maintain it, and I took it over. Nitrogen is an event-driven web framework, and I think it's the only one up here that's represented that it actually includes JavaScript in the as part of the framework itself, and it uses that to abstract away the events in the form of postbacks that get sent to the server and then they get pattern matched against. And that's a pretty convenient way, and it's a very common kind of mechanism for building GUIs in using the event-driven format, and that's what makes Nitrogen an effective tool for building GUI-based web applications for very simple, for building simple GUI-based applications. And then the other thing that makes Nitrogen so interesting is the use of Erlang records extensively, which most people who know Erlang and have done Erlang long enough, they're like, oh, Erlang records, and that's why everybody's looking forward to maps. The use of Erlang records in Nitrogen makes it kind of unique and is, I think, a fantastic use of Erlang records in the way of kind of mapping the Erlang records. They're called Nitrogen elements. They map to HTML tags, essentially, and they provide an Erlang-y way of representing HTML tags without having to write HTML code. And that gives you a solid level of abstraction that you can use for building these GUIs in raw Erlang without having to write any HTML. And as well, there's actions, which are also Erlang records, that abstract away JavaScript events. So in a sense, you can write a full-featured, like, web JavaScript-rich Ajax-y application without writing, like, 100 lines of JavaScript maybe. You can write your whole application in Erlang server and without having to resort to, like, writing raw HTML. So that's kind of what makes Nitrogen interesting.
So is this GWT for Erlang?
Is it GWT?
GWT? Where you're writing a full stack app, JavaScript, HTML server side in that case Java.
I mean, kinda. You are writing your full application, but I honestly haven't done Java much at all. I don't remember.
It's fair.
I wrote like GUI Java applications in college, and I don't remember any of them.
Yeah.
I don't remember what I did.
Sounds like it. Yeah.
Yeah. So
It's pretty popular.
My name is Evan Miller. I develop the Chicago Bus web framework. It's sort of a Ruby on Rails-ish web framework. I got started with it because I was a Rails developer a long time ago. And there are a lot of things that I liked, but I hated basically all the runtime characteristics. I was also an Nginx developer early on, and I really liked this sort of the single-threaded async non-blocking magic that could allow you to have like 30,000 connections at the same time. But I really didn't like writing callbacks, which I discovered a long time ago, and I think no developers are just discovering now. And so it started out with some code, I guess, like 5 years ago. The project was officially released 4 years ago, and I've been working on it since then and had a lot of contributions. So it has a built-in email server. It's got a built-in database abstraction layer, and it can connect to 5 or 6 different databases, MySQL and PostgreSQL, which is sort of a unique aspect of the framework that a lot of other ones sort of are more database agnostic. And the other thing that sets it apart is that there are a lot of parts of Erlang syntax I really don't like, so I sort of bent over backwards to hack the compiler to have like these terrible syntactical constructs that save me typing. So a lot of people really don't like that. But if you don't like typing, it's a great framework. And you should try it out.
Hi, I'm Sean Cribbs. I also work at Basho Technologies. And we make Webmachine, which you've already seen a little bit from Chris. Actually, he showed you a lot of Webmachine. But Webmachine came about, I believe, in 2006 or 7, in Basho's previous incarnation, before we became a real technology company, sort of a software as a service company. And they were building out infrastructure for the service, and the experience of a few of the engineers there at the time, from previous work on high availability systems, high-scale web systems influenced its design, and mostly the idea about being able to reason about HTTP in a functional way. And Webmachine really reflects that. Instead of having a framework that has some sort of Model 2 MVC type of thing, or being this sort of raw, you get like a servlet, like where you get a request and you just kind of have to do with it whatever you want. Webmachine says you're going to map various path patterns to resource families, and those resource families are modules which define functional predicates over the request and response data. So you're basically writing facts about your resources rather than writing what to do when you get a request. And I think that aside from that, the thing that makes Webmachine distinctive is that, and of course the visual debugger, which Chris showed up a picture of, is that you basically can pick whatever you want. It's a resource server. It doesn't provide a database. It doesn't provide a templating language. It's not a web framework. It's more of a toolkit.
So how many people here would consider themselves web programmers? Write software for the web. It's becoming pretty much the ubiquitous model for building software. If it's software to be built, it's going to be a web application in some format. So I think one of the questions, if I was approaching Erlang afresh, would be, Erlang has this reputation of building highly available, fault-tolerant, scalable systems. Now that of course applies to the web naively. But having built these frameworks, supported user bases, what would you say is sort of the secret weapon in using Erlang? Why Erlang in your particular case? Evan.
Oh, wait, sorry. Do you mean the secret weapon when, like, my secret Erlang trick that lets me bust on my Erlang, or why is Erlang my secret weapon?
Yeah, the second.
Yeah, it all comes down to the VM for me. So there are a few aspects. One is this non-blocking nature that I talked about. So with Erlang, you can just write dumb sequential synchronous code, and the runtime system actually will execute it in an asynchronous non-blocking way. So it'll only use one operating system thread or one operating system thread per core, even though you have hundreds or thousands of concurrent requests, and then those processes don't get in each other's way. So it's really great, just in terms of the CPU usage perspective. The other part for me is from a memory usage perspective. I use a template library, this early DTL library, and Erlang is great for serving templated web pages across concurrent requests. And the reason for that is this data structure called the IO list, which can also use these shared binaries. And if you have, say, like a template snippet, you've got a header and a footer. In most other languages, when you're serving up a template, it'll just start with an empty string, and then it'll concat the header, then it'll concat some other data, then it'll concat the footer, and then it'll send it off. So you have to copy the memory and the data several times into this string that's being built up before it gets sent off. In Erlang, you use these IO lists, which are essentially constructing a tree of pointers to the same piece of memory. So you only have to keep one copy of the header and one copy in the footer in memory, and all the concurrent requests can just say, oh yeah, now I want the header, and now I want the footer. So you use a lot less memory, and you have a much better CPU cache hit rate. So the performance is as a result much better. When I was a Ruby on Rails developer, I found out the template rendering was usually the bottleneck in those applications, and I think that's one of the reasons a lot of web developers have moved to very client rich applications, is just avoiding this 2 second, 3 second, 5 second rendering time. You don't see that with Erlang applications that take advantage of IO lists and binaries. So you can kind of do these old school server-side templates, and they're very, very fast. So that's why Erlang's my secret weapon.
Yeah. So this would be a case where immutability, where you think naively, if immutability would cause performance penalties. In this case, because there's no risk of overwriting it, it allows concurrent access to these shared structures without any threat of
exactly
of corruption. Secret weapons, Steve.
I agree with everything Evan said, but in addition, as a developer of server-side things, the tracing that's built into the Erlang VM is incredible. Like in the 7 years I've been doing Erlang, I've used the debugger twice. I only had it because I needed to see something in a way that I couldn't normally see with tracing. But with tracing, it's on you just turn it on in the VM, and you can trace calls that are going through the VM. You can look for certain argument values going into a function. Say, trace this function when I see this argument coming in at this value. You can trace timestamps to see where you're spending time. It's just incredible, and it's all built into the VM. And in fact, I've given users of Yaws, sometimes Yaws users are trying to do things, they get themselves, it doesn't happen very often, but you get like a new user trying to do some big heavy thing and trying to learn Erlang and Yaws and everything at the same time. They get a little flustered. They might have some bad code that they wrote and they don't know where to go, and I'll say, turn on this tracing like this and send me the output, and I can look at it and go, oh, this is what you're doing. And it's fantastic.
Continuing on that idea of live tracing and debuggability, I think one of the most important things, not just with web frameworks, but also when we're supporting React customers, is to be able to connect to that Erlang console and immediately interact with things that are going on in the VM. It amazes me how many environments, programming and deployment environments, don't have a live console. And if you can do that with your Erlang app, then you can do all sorts of awesome things like kill a process that has bad state and replace it with new code live without taking the system down. And I think that even if you're not using the hot code reloading with the app upgrades and the release upgrades, you can even just go in there and poke at the code as it is without interrupting regular operations. That's incredibly powerful.
Sean, would you say that that's like an operating system for your code?
Absolutely, I would, Garrett. Good. I'm glad you mentioned that.
Yeah, it just sounded like that to me. It just evoked that. Todd, yeah.
One of the things that I'm sorry, I totally skipped over you. One of the things that kind of drew me to Erlang, I unfortunately come from a bit of a PHP background, but maybe I'll just switch back to using PHP and Yaws, and then I'll be all good. But one of the things that was good about the PHP and Apache model, despite the pre-fork and the ridiculous use of RAM and the total mess there, was you still get the process isolation. You just get complete OS process isolation, which was nice. And then going to Erlang, where it's like you have this total process isolation, but you also have the benefit of having a virtual machine and the triviality of communicating between different connected users without having to deal with like a third-party library or something to do that. It's built right in. It's baked right into the code operating system, if you will. The communication between connected users while maintaining that process isolation that comes naturally with Erlang. That was a big win for me. It was kind of like a whoa, dude moment. So
That's the kind of ecstatic reaction that I think it's appropriate. Yeah, I think that's about right.
That's about right.
Yeah.
I know for me, I've used the debugger a little bit more than Steve. So, in that case, I remember watching a Java presentation we had at work, essentially saying, hey, "Oh yeah, if you want to do concurrent unit testing, things like that, or reason about the system with threads, don't. You just it's too hard." And when I've run the debugger, I mean that's the great thing is like you've got it's a full-on process. It's a small process, like tiny, right? But it's you can use the debugger and you can see messages coming in, and you can say, oh, this is this message is coming in. It's not getting handled by the code that I think it is. That's what's wrong. As opposed to when you're trying to do something similar in Eclipse and Java with threads, all of a sudden you're reading through one part of the stack, and then it switches over because the other thread takes control. It's like, wait, where am I? And that made things a lot easier to reason about. And the other thing I really liked is, I think as I'd mentioned at the outset, is that it's amazing how much horsepower you get out of Erlang just at the outset. There's very little code here, and I figured I need to do some performance testing and load testing with the application. And all I did is I stood up a local instance of, and I'll probably slip and call it the tea kettle a few times because that's what it is internally. So if I say tea kettle, that's our Erlang application. And so I had one instance deploying, just trying to hit a few test servers that were in Tomcat, and I'd keep knocking Tomcat servers over. So I'd have to keep going out to find dev boxes to sort of stand up something just for, for an application running on my box. And it was amazing to me, like how little effort that took. It was very, very powerful. It was great.
So let's talk a little bit about scalability, because scalability is, especially web scale. Okay, that's the title of this talk. So we could talk about web scale. Is Erlang actually web scale? Is it web scale? So let me throw this out. So you used to run benchmarks out of curiosity across a bunch of different frameworks and language environments. And between PHP, mod PHP, and Apache, that combo, and Erlang were the two standouts. And the performance characteristics that I've observed with Erlang were notable in that you couldn't bring the server, like you could scale up, you could throw a huge load at it. What was remarkable was that it didn't get corrupt. It would recover. None of the other environments, including PHP, survived very long after this barrage, but Erlang did. And that was my ad hoc analysis. You guys have seen more use cases and live cases. Is this fact or fiction from your point of view? Is it just a video? Is this just video content that we're putting out here? Who wants to talk about that?
Yes.
Agreed. Done.
Drops mic. Okay. Well, if you go out on the web, you can find this graph, which was from Yaws, I think from 2007, which is Yaws versus Apache. And it shows a cluster of, I think, 16 machines kind of throwing a load at some other machines. And the Yaws system is handling 80,000 requests or something like this. It's just steady, kind of flat across the top. And then Apache is kind of down here somewhere, and it goes like that. Now, that's a few years ago, so things have changed, obviously, both in hardware and software. But the people who use Yaws use it in production. They put it out there, and it just keeps going and going. And there are websites out there like Klarna has been using it for years. They're a financial website, so obviously the website has to be up because they're doing all their business on the web. And it just keeps going. They have lots and lots of customers, so it must be scaling. There's Christopher Fallet. I don't know exactly who he works for, but I know they use it in production. Lots of hits on the website and everything. So, yeah, it just kind of, you get it going and it just keeps running and running. And like Sean said, if you really want to update it or have to fix something, you can do that on the fly. I've done that in the system I used to work on before I went to Basho. We used to, we're working on a system that was kind of under development. So customers knew it was a prototype. They were using it, some of them using it in production, and they'd hit a problem, and I'd get on their machine, do a hot code load, keep running, and connections maintained and everything like that. So it's pretty amazing.
Anybody?
I'm trying to remember what the question is now.
Is it web scale?
Oh, is it web scale?
Yeah.
So, like, when people say web scale, they, obviously, the origins of the term is kind of loaded. So I want to address that. But like, when you have a large production web system, you typically have multiple layers of network things. You have, load balancers and whatnot. And one of the big problems is, like, denial of service attacks, right? So somebody just like opens a bunch of connections and tries to hammer your system. The nice thing about Erlang is if they're like trying to do like a buffer overflow attack or whatever, you can just choose not to read from the socket, and or you can just read a little bit, and there's a lot of ways that activity, because it's inside a process, it's isolated from the other processes in the system, you're less likely to take it down. You can also just let the process that's handling the request die, and that connection goes away, and that person gets some kind of TCP backoff thing or whatever. But the core core thing I'm trying to drive at there is that the isolation in Erlang's design, if you have a process per connection, which is the typical pattern in Erlang, that you can isolate any clients from one another, and they basically don't affect each other.
So we have a few minutes left. Let's open this up to you folks for some questions. Hard questions. Just unleash. Hold back nothing.
Have you ever tried to upgrade one of your frameworks on a running system?
So the question, have you ever upgraded a framework on a running system?
Yep. Like yesterday. That was just fine.
Now, is this a question, have you tried to do that, or have you succeeded in doing it?
Oh, sure. Yeah. It's not a big deal. With a product I run, I typically, if I really want to upgrade it, I won't do I honestly haven't experimented much with the rel up process and that whole, because that kind of scares me a little bit. I should use Relics. I've been reading all about it, and I'm like, oh, Relics looks awesome. I need to do it. But I just haven't. But, I mean, I'll just turn on Sync, which is like an automatic code recompiler, and I'll download everything, and it'll recompile all the code, and I'll run some quick script that copies any necessary JavaScript changes to the live site, and we're good to go without changes, without breaking anything.
Question?
Yeah, I mentioned in my previous response, I mentioned that we were working on a video server, and it was using Yaws, and we had a value serving what we called in that industry high value video. You know what I mean? And so they don't.
This is being recorded, so I'm just going to keep all the jokes.
They don't necessarily
To myself.
want those connections to drop, and if you're hot code loading, you don't want to take that server down. And yeah, it works.
Puns just run through one's mind, don't they? Yeah.
Do you guys think that there's like a lack of maturity in terms of libraries for things like database drivers and cache systems that have maybe hindered adoption of people using Erlang for web frameworks, REST APIs, things like that?
So the question is, given the lack of maturity of many libraries in the Erlang ecosystem, has that hindered the adoption of Erlang as a web platform?
I think so. I mean, I guess the rule of thumb I've had is that if there's any functionality you're looking for, there will be 0, 1, or 2 Erlang libraries that implement it. And it's getting a little better. We're starting to see some maturity with some of the more popular things like MySQL drivers. Some hero has been like rounding up the like various forks. There's a great README somewhere that just like documents the history of this like sorted history of MySQL drivers. But yeah, you have to like learn all that like crap like that just to get productive, which is still a shame. But yeah, I think for the major functionality, it's starting to settle into place a little more. What we're really missing though is sort of the long tail of functionality that, you're starting a web service and there's something that you're looking for, like a geocoder or just some little bit or a wrapper for some REST API out there. There's a good chance that's just not there, and you're going to have to be doing that yourself. And I think that's a significant disadvantage compared to the more mature communities out there.
I'd say as a counterpoint to that, while there aren't as many libraries available for things, there are some communities, for example, Ruby I'll pick on a little bit because I program Ruby too, where they have way too many things for the same purpose. And so you have to like weed through a bunch of possibilities. Whereas in Erlang, because it doesn't have as many, you often have the opportunity. I mean, if you were writing something for a geocoder, they're probably going to have a simple API. You can use the Erlang's built-in HTTP client and just send a request. Like maybe I'm getting jaded about using other people's code anymore, but that you have a lot of tools there, and actually there's a lot of for lack of a better word, hidden gems in Erlang's standard library, and you just have to dig for them.
We have time for one more question. 0101, yeah.
So I guess to sort of piggyback on the lack of these jams, how do you overcome sometimes the reluctance of the management of the company to invest more into Erlang, given like that's like a very often cited reason for saying, well, you know what, it's really not for web, it's not for mainstream, it's specialty language.
Start your own company.
Yeah.
That was my solution.
So the question is, how do you overcome management or sponsorship objection in adoption of Erlang, given that its reputation is not in the web sphere? So, Jesse's start your own company. Yeah. Yeah. This Todd. Can,
Yeah, I don't really have an answer either, Alex. Once you figure that out, let me know. Well, you three definitely hear everything that I say consistently. What's that? I just try and make whatever case I can when possible. I'm a great example. I started out as a Java developer. I didn't have any Erlang experience. I kind of got fed up. Like, concurrency in Java literally gives me headaches because I can't keep the model in my head. It's too hard to figure out what's going on. And I kept seeing new libraries about how threading's easier here, threading's easier there. I thought, well, yeah, kind of. It makes it a little bit easier. But eventually I stumbled onto Erlang, and I was lucky enough to have a resource at Orbitz, Martin Logan, who was, literally wrote a book on Erlang to help guide me at first. And then I got the tea kettle dumped in my lap, which was a great blessing eventually. Not the first day, but and so I learned Erlang basically on the fly at the company that that I'm trying to convince should use more Erlang, because there are certain sweet spots I think where it's useful, and all I can do is just be slow and steady and patient. If anybody has a great way to say, hey, this is how you get a new language introduced and we can start using it tomorrow, let me know. I'll be more than happy.
I think along the same lines, my motto is ask forgiveness, not permission. Right? So what you can do is just start the project kind of on the side. Maybe you're going to have to do kind of double the work because you're working in your approved language and this other thing. But you just start showing what it can do. And that involves giving internal talks, might involve dragging people over to your desk and saying, look at this, is this cool or what? And every little bit of that just adds up and starts to build a bit of an ecosystem. And so the company that I mentioned before, it was about 50 C++ developers primarily. And I was the only Erlang person. I was sitting there and someone walked by my desk. What's that? It's Erlang. What are you doing? Oh, I'm doing this. And they're like, I want to do that. And it just caught on. And then, eventually I had about 8 people I'd trained how to use Erlang. And we were doing, I'd say, quite a bit of work in terms of what we were delivering compared to the larger team. And, just, like I said, it just catches on. If it's as good as the panel says it is, it's going to catch on. And I think we'd all agree that it's that good.
I actually have to play us off here. I'm going to sing. I'm going to literally.
I'll be
okay,
15 seconds.
Yeah.
Just to piggyback off of Steve, if you're in the Chicago area, get your company to let us have a Chicago Erlang user group meeting at your company.
There you go.
And just have some of your employees hang out.
It's a good plug. Good 15 seconds there. Yeah, we have a user group in town. So if you're not on that list, go to meetup.com. Go to Meetup, sign up, and then you'll get low spam. Good list. Yeah, we have good meetings. Thank you very much for coming. I appreciate your time, and I think this is for me, this is a really fun time. So I need to.